welcome to the course Excelling with Mathematical Modeling. We all have bank accounts. We are familiar with the loans, with the mortgages, with the credit card bills and so on. So today we will be looking up into some bank account problems that we usually face in our day-to-day life. So let's consider that you have a savings account which gives you 4% interest compounded yearly. Generally, it does not happen in a savings account, but somehow the banks offer this kind of offer which gives you, okay, you open a savings account with us, we will give you 4% interest compounded yearly. So, you make an initial deposit of say rupees 10,000 to start with, and you say that at the end of each year you will deposit rupees 5,000. So, the bank says okay, so the interest will be added, and then at the end of next year whatever the amount is, we will again give interest on that particular thing because it is compounded yearly. So, if you want to model this kind of situation, so you take say AN, that is the amount at the end of year n. So, what will be your A1? If I take say R to be my rate of interest, then I have my initial deposit A0, the rate of interest is R multiplied by the initial deposit A0, and I get 1 plus R A0. And please note that this rate of interest, this is usually not given in percentage, but if it is given in percentage, you have to divide it by 100, and then that value will become the R. So, in the second year, I have my new principal, which is A1, and rate of interest multiplied by A1. So, 1 plus R into A1. In the similar manner, it will go on, and in the n plus 1th year, I will have AN plus R times AM equal to 1 plus R into AM. But now you said that okay, every year I will be adding 5,000 rupees, which is a constant thing. So, if I want to model that, that is AN plus 1 equal to 1 plus R AN plus rupees 5,000 for every year. So, if I put n equal to 0, I will get A1, this will be A0, which is this, but then plus 5,000. So, if you now want to calculate what is your A1, your rate of interest R is 4%, and as I told you, you have to divide it by 100 to make it 0.04. So, A1 is 1 plus 0.04, so 1.04 multiplied by A0 plus 5,000, and this will give you approximately 10400 plus 5,000, which is 15400. Similarly, my A2, it is now the new principal 15000 multiplied by 1.04 plus 5,000, and this is approximately 21016. Similarly, A3, my new principal, which is 21016 plus rupees 5,000, and this will approximately give you 26857. and so on. So, we can get what is the amount at the end of whatever year you want. Now, let us consider a different scenario. So, in this particular scenario, no deposits are made. So, your model was a n plus 1 equal to 1 plus r into a n initially, and then we said that every month we add this 5,000 rupees to it. So, you have added 5,000, but now this 5,000 will not happen, no deposits are made. Instead, rupees 2,000 is withdrawn at the end of each year. We keep the rate of interest at 4%. So, if we calculate R, which is 4%, which is 4 by 100, so this remains same, 0.04. So, what you want to know is that how much initial deposit you must make such that your balance is never 0. So, to find that, there are two assumptions we just take. First is the money is withdrawn after the interest from the previous year is added. So, you can only withdraw the money once that interest is deposited in the account. And number 2, no penalty for withdrawing money. See, the bank has given a special offer. The offer is that yes, it is a savings account, but then your interest gets compounded. In such a case, the bank can put some clause that okay, if you have an early withdrawal, then we will put a penalty. But in this case, there is no penalty on withdrawing the money, and money will be withdrawn after you have deposited, after the bank deposited the interest. So, with these two assumptions, we need to find that what will be the initial deposit such that it never run out of cash. So, you have to deposit the initial amount in such a clever way that with this 0.04% interest, you will still have, and your constant withdrawal of rupees 2,000, you will still have money in the bank. So, if you want to model this, this part remains same, that is a n plus 1 equal to 1 plus r into a n, but then you are withdrawing the money. So, minus 2,000 every month, and your r, as told, it is 4%, which is 4 by 100, which is 0.04, and this is equal to 1.04 into a n minus 2,000, this is a n plus 1. So, this is the model which you get for this particular scenario. Now, to get the initial deposit, what you have to do is, so you are withdrawing 2,000 every year, and if there is no change from one generation to another generation, that is from 1 year to another year, then what you get is the equilibrium solution. So, basically you have to get that equilibrium solution such that your account never run out of cash. So, if there is no change from n to n plus 1 generation, then you take that value to be a star, which is your equilibrium solution. You substitute it here. So, you get a star is equal to 1.04 a star minus 2,000. So, 0.04 A star equal to 2000, and this gives you your A star equal to 2000 divided by 0.04, which is 50,000. So, if you make a initial deposit A0 to be 50,000, you will see that you never run out of cash. So, for example, if you take A1, which is 1.04 into A0 minus 2000, and substitute this A0 here, you will get the same 50,000 back here. Let us now see the numerical solution of this with the help of Microsoft Excel to see that whether our analytical result with it matches with the numerical one. So, this is my n. So, for x1, x2 and x3. So, I have three solutions here, or rather you can put it as A1 because we have taken the equation in the form of A, but I guess you understand that. So, why these three values? That is because we will start with initial amount of 50,000, and we will see what happens if it is less than the chosen initial amount and greater than the chosen initial amount. So, this value is equal to this plus 1. So, I just give an increment of 1, and let us calculate up to 40 of them. This value is equal to, so I will use this equation. So, this is n equal to 0. So, this is A1 and this is value is A0. So, A1 is equal to 1.04 multiplied by A0 minus 2000. So, you see you get this 50,000 back. Here also equal to 1, that is your initial value A0 multiplied by 1.04 minus 2000, and here 1.04 multiplied by the initial value of 60,000 minus equal to 1.04 multiplied by 60,000 minus 2000. So, let me calculate the next 40 values. You just drag them. Let me increase their font size. Say 20, make them bold and make them in the center. So, now let us plot and let us see what you get. So, go to insert, go to scatter diagram and choose this one. So, you get something like this. Okay. So, let me now explain it from the slides. So, we have this kind of chart which you can see on the slide. So, when this is 50,000, you get a constant one. So, if you make your initial deposit to be 50,000 as shown analytically, your account will maintain 50,000 throughout, and even if you deposit 2,000 from here, this is going to maintain 50,000. So, the cash will never run off. So, that is the problem which we are facing and we have solved it. But obviously, you will be curious what will happen if A is less than 50,000. Then you can see that slowly your amount is decreasing and ultimately goes to 0. And if it is more than, this greater than, if it is greater than 60,000, sorry 50,000, then your amount will increase and it becomes an unbounded solution. So, basically these two solutions are needed for a real life scenario. But again, if it is more than 60,000, your money will keep growing till there is any change in the rate of interest or in the initial amount. Now, let us change it into a loan problem with the same setting. Say a person wants to take a loan. So, in that particular case also you have the payment which will depend on the rate of interest, and then you make a monthly installment of D. So, let us assume that the bank charges 12% interest annually. The monthly income of the person, say 96,000, and the bank put a clause that monthly installment cannot exceed 1/4 of the monthly income. So, your maximum repayment of the loan will be 8,000 divided by 4, which is 2,000. So, this is say yearly income. So, this divided by 12 will give you 8,000 and 1/4 of the loan is 2,000. Your monthly rate is 12%. You take the percentage 0.12 and you divide it by 12. So, 0.01. So, if you now put everything here, and this P n plus 1 equal to 1 plus R times P n minus your installment, and we know the solution of this is P 0 1 plus R to the power n minus D times 1 plus R to the power n plus 1 minus 1 multiplied by 1 plus R minus 1, which is R. This is the solution. Now, say he took the loan for 25 years, which is 300 months. So, if you sum up this problem, that this is now a loan which has been taken from the bank. So, how it works? This is the amount for n plus 1th year, this is the amount for the nth year. Bank will charge an interest for R on the principal that is there and minus the monthly installment. So, this is the monthly installment that you paid. This is the monthly amount that has been accumulated, and this is the installment you pay. Your rate of interest is R. So, if your yearly income is 96,000, you divide it by 12, which comes to 8,000, and bank put a clause that you cannot pay more than 1/4 of the monthly income, which is 2,000. Your monthly rate will be 12 is your annual rate divided by 12 and then divide by 100 and you get it 0.01. This will have a solution in this form. You substitute everything here and you say that in 300 months my loan amount will be 0. So, you put this equal to 0, your initial amount you want to calculate. So, what will be your P0? This is 1.01 whole to the power 299 minus D is your 2000, then 1 plus 0.01 to the power 300 minus 1 divided by 0.01. If you solve this equation, you will get your P0 is approximately equal to 189894. So, if you take this much amount of loan, that is the maximum amount this much, then you will be able to repay back in 300 months. We now look into another interesting model. We name it as retirement investment or account model. So, often you visit bank, this personnel, they suggest you different schemes where you can investment. So, this retirement investment or retirement account is one such scheme. So, suppose a person who is doing a high profile job, he went to the bank and the personnel suggests that you must have a retirement account. So, what they are going to offer? So, they say that, say in this account he will earn 0.75% per month. Also, with his high paying job, he will be able to invest rupees 20,000 per month. And to take care of the inflation, and of course, there are pay raises, it is suggested to increase this amount. By this amount means this 20,000 by 0.5% per month. Now, to see what will be the accumulation of the fund, say after 20 years. So, if we want to find that, what will be the accumulation of his account or fund after 20 years, which is 240 months. So, we are going to model this situation where a person went to the bank and he had been asked that you please invest in this retirement scheme, and in the scheme they said that you will earn 0.75% every month, which is 9% per year, and if you invest every month 20,000, that is the initial investment, and let us find out what will be the amount after 240 months, and it is suggested that every month he should increase this amount by 0.5% to keep into account the inflation and the pay rises. So, if we want to model it, so let us say this AM, that is the monthly amount after n months in the retirement account. And say R be the inflation rate. So, you have AN, which is AN minus 1 plus R AN minus 1. So, I can write this as 1 plus R into AN minus 1. This is your AN. So, your A1, which is 1 plus R into A0, your A2, which is 1 plus R into A1, and I can write this as 1 plus R into 1 plus R into A0. So, this becomes 1 plus R into A0, 1 plus R square into A0. Similarly, your A3 will be 1 plus R cube into A0, and we can generalize it as AN as 1 plus R to the power n into A0. So, this is one part. Let us take another variable Bn. So, this gives the balance in the retirement account after n months, and let us your I be the interest rate and B0 is your initial value. So, let me write this AN one more time. This is 1 plus R to the power n A0, and let us now formulate your Bn. So, which is Bn minus 1 plus the interest rate on Bn minus 1 and plus the monthly amount. So, if I want to find B1, so this can be written as 1 plus I to the power Bn minus 1 plus An minus 1. So, this will be B0 plus I times B0 plus A0. Now, initially B0 there is no balance because the initial investment start from here, which is 20,000. So, your B0 is 0 in this case. So, you are left with only A0, the initial balance. Your B2 will be 1 plus I into B1 plus your A1. So, 1 plus I, your B1 is A0 and your A1 from here it is 1 plus R to the power 1 into A0. Let us come to now B3. So, if I substitute it here, I will get 1 plus I into B2 plus A2, and this will be 1 plus I. So, B2 is this, which is 1 plus I into A0 plus 1 plus R into A0 plus your A2 gives 1 plus R whole square into A0. So if I multiply, I can write this as 1 plus I square plus 1 plus I into 1 plus R plus 1 plus R whole square into A0. And this can be written as 1 plus I cube minus 1 plus R cube divided by 1 plus I, 1 plus R. So basically what you got here is something of the form a square plus ab plus b square. So if I multiply this by a minus b and a minus b, I will get a cube minus b cube divided by a minus b. So this is exactly what you got here. Let's quickly check with b4. This will be equal to 1 plus I into b3 plus your a3. And this can be written as 1 plus I. So I write the b3, which is 1 plus I square plus 1 plus I into 1 plus R plus 1 plus R square. This multiplied by a0 plus a3 is going to be 1 plus R cube into a0. So if I multiply this, I will get 1 plus I cube plus 1 plus I square into 1 plus R plus 1 plus I into 1 plus R square plus 1 plus R cube into a0. And this can be written as 1 plus I to the power 4 minus 1 plus R to the power 4 divided by 1 plus I minus 1 plus R into a0. So if I want to get the formula for Bn, so I have to just follow the generalization. This will 1 plus I whole to the power n minus 1 plus R whole to the power n divided by I minus R into a0. So this is basically what you get after the simplification of the model. So let's now find what will be his funding after 240 months. So I write the formula one more time, which is Bn equal to 1 plus I whole to the power n minus 1 plus R whole to the power n divided by I minus R into a0. So according to the problem, your a0 is 20,000, your I is 0.75%, which is 0.0075. Your R, it's going to be 0.005, and we substitute all this value here for n equal to 20 years, which is 240 months. So if I substitute Bn, this will be equal to 20,000 for this a0, then 1 plus 0.0075 to the power n, 1 plus 0.005 to the power n, which is 240 in this case, divided by I, which is 0.0075 minus R, 0.005. So if you simplify this, it will come to 8 into 10 to the power 6, and this is 1.0075 to the power 240 minus 1.005 to the power 240. and if I multiply this, I will get the answer as 2159156.39. So, almost more than 2 crores that he will get after 20 years. Let us now check this result numerically. So, I already have the model here in the form of basic equations, which is a n equal to 1 plus r into a n minus 1 and b n equal to 1 plus I b n minus 1 plus a n minus 1. So, the initial condition is there is no balance, which is 0. This value is 20,000 with which he starts. Your value of r (0.005) and the value of I is 0.0075. Just change the font size and make it bold and center. So, let us first calculate this AN. So, this is equal to 1 plus R, 1 plus, so though it looks like 0.01, let us now calculate this value of AN, which is equal to 1 plus R, which is a constant, multiplied by A0, which is this value, and you get the value. And this is equal to 1 plus I. So, 1 plus I, which is again a constant, multiplied by B0, initial value is 0, plus A0, which is this. Let me now drag this to the next 240 values. So, if we want to plot this, so I want to see what is the balance. Basically, I want to see this Bn. So, I will highlight this first. Up to 240 values. And then I will take the third column. So, I press Control, I click this, then press Shift and the down cursor. So, it will choose all the 240 values. I go to Insert, I go to Chart and I plot this. So, I can write this as retirement account model. I remove the grid lines. If I want the access title, so this is the month and this is the amount. amount in rupees. So, if I want to see what is the amount after 240, so I can just bring the cursor here, and as you can see it is written that 0.240 and the amount is 21591576.39, which matches exactly with the analytical solution, this 21591576.39. So, with this we come to the end of this lecture, where we have taken few examples that is related to the bank and its accounts. So, in my next lecture we will be talking about some economic models, discrete economics models. Till then, bye bye.